Hello and welcome to The Explainer. I am genuinely so incredibly excited to be here with you today because honestly, we are about to completely shift your entire approach to Cambridge IGCSE Physics. Let's be real for a second. If you have been relying on rote memorization to just barely scrape by, cramming formulas into your head the night before and hoping for the best, it is time to throw that outdated, stressful strategy right out the window. Today, we're transitioning to an application-first strategy. Think of it like an archaeological dig. We are going to uncover the hidden clues in the exam questions and layer by layer reveal the perfect answer. We are focusing specifically on a micro-topic that absolutely affects literally everything else you will study in this syllabus, a system of units. Now, I know what you might be thinking. Units? Really? That sounds kind of basic. But listen to me. This isn't just about memorizing random letters to stick at the end of a number. Understanding systems of units is the fundamental blueprint for unlocking those top-tier marks. It's the foundation of everything. And in this session, we are going to decode exactly how to apply it to your studies right now, so you never drop easy marks again. Let's get into it.
Okay, let's dive right into this by making the idea of units feel absolutely necessary rather than just decorative, because that's a huge problem, right? We treat units like they're just the garnish on the side of our math plate. But before we even touch formal language or complex math, I want you to ask yourself, what physical effect, measurement, or prediction actually depends on understanding a system of units? Framing your study session around this simple yet profoundly deep question stops you from relying on memorized wording alone. It actively trains your brain to reason its way through those completely unfamiliar, tricky curveball exam questions that Cambridge examiners absolutely love to throw at you. When you know the why behind the unit, the how becomes so much easier. We're going to decode this module through a highly structured strategy masterclass. Here's the agenda. 1. The real-world hook. 2. The 4-step blueprint. 3. Translating everyday language. 4. Avoiding common traps. And 5. The ultimate memory prompt. Starting off with Section 1, the real-world hook. Let's look at why this is so essential.
You have to understand that this stuff isn't just locked inside a textbook. Whether you are dealing with cutting-edge engineering, life-or-death safety protocols, transport networks, massive energy systems, global communications, advanced medical technology, or even astronomy, units are the absolute foundation holding it all together. I want you to think about the 1999 Mars Climate Orbiter. Have you heard of this? It was a literal $125 million disaster. The spacecraft completely crashed and burned in the Martian atmosphere simply because one engineering team used metric units and another team used imperial units. Imagine making a $125 million mistake because of units. That brilliantly illustrates why you should always be able to name at least one concrete situation where the concept you are studying actually matters in the real world. Why? Because knowing exactly why the physics helps us predict or improve outcomes is exactly what examiners are looking for. They don't want human calculators, they want future scientists.
So, the absolutely crucial point here is that whether you are dealing with fields, forces, particles, circuits, or waves, physics is fundamentally about cause and effect. It is never ever about isolated facts. When you deeply understand the cause and effect within a system of units, you can actually predict outcomes. You know what's going to happen before it happens. And that predictive power, that is the true essence of physics. That's what gets you the A-star.
Let's move right along to Section 2 and uncover the ultimate framework for structuring your exam answers.
If you really want to impress an IGCSE examiner and practically guarantee those top marks, your answers absolutely must show both deep understanding and real-world application. It's not enough to just know the fact. You have to show how it works. You can achieve this reliably, time and time again, by following these 4 tightly linked steps. First, you identify the quantity or the phenomenon. Just name what we are looking at. Second, you state the relationship involved. How do the variables interact? Third, you explain the underlying physics. What's the mechanism? And fourth, you connect it to an observation, an experiment, or real working device. It is a highly logical sequence that leaves literally zero room for ambiguity. It boxes the examiner into giving you the marks.
Now notice how we could distill those 4 steps into one powerful, easy-to-remember acronym. We call this the DREA method. That's definition, relationship, explanation, and application. By internalizing this DREA framework, you are essentially building a bulletproof cause and effect chain. This is, without a doubt, the safest and most effective exam answering method out there. Frankly, it is exactly the kind of structured, mature reasoning that examiners absolutely love to see on a test paper. It shows you're not just guessing, you have a system. Before we continue, subscribe to our YouTube channel, AC Exams, at @ACExams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay,
Now let's explore Section 3, where we tackle how to bridge the gap between your normal, everyday descriptions and precise scientific wording.
A really brilliant way to approach an explanation, whether you are studying late at night at your desk or sitting under pressure in the actual exam hall, is to get the idea straight in your head first using just normal, everyday language. Don't overcomplicate it right away. For example, you might look at a scenario and start by thinking, okay, the car is speeding up. That is your foundation. You've recognized the physical reality. Then, you deliberately and gradually transition into specific physics vocabulary. So, the car is speeding up becomes, the car is accelerating due to a net force. See the difference? Once you have the precise words locked in, then you introduce the symbolic relationships or the formal definitions. It's a stepping stone approach. It prevents you from getting completely tangled up in complex formulas before you've actually grasped the core concept.
And listen, if your specific topic involves graphs, which, let's face it, this is Cambridge Physics, it is highly likely you're going to see a graph, you absolutely must always translate the visual data into physical realities. You must stress exactly what the slope, the area, the direction, or the shape means physically. A slope isn't just a mathematical gradient drawn on a piece of paper. In a system of units, that slope might actually represent acceleration. Or maybe it represents resistance. The area under the line might be the total distance traveled. You have to translate the math back into the real world. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's keep the momentum going. It is time to put on our examiner lenses for Section 4 and identify exactly where students are needlessly throwing away precious marks.
Have you ever just written down a formula and moved on, thinking you nailed it? Merely writing a correct formula without explaining the variables is a massive, massive trap. We actually call this the naked formula error. Writing down F equals ma completely on its own might, if you're lucky, get you a single sympathy mark, but linking those formula components directly to physical effects, for instance, explicitly explaining that the force F is the thrust of the engine, the mass m is the rocket itself, and the acceleration a is its change in velocity over time, that is the winning strategy that secures full marks. You have to dress the formula, give it context.
There are 2 other major, critical errors you must strictly avoid. First, quoting a process without linking it to a physical effect. And second, giving an example without showing why it follows from the physics. You cannot just drop real-world examples in isolation and expect the examiner to hand over full marks. They won't do it. You must always justify why your example works based on the underlying physics of the system or units. Your justification is the bridge. It connects your theoretical knowledge to the real world. And honestly, it's the glue that holds your entire exam answer together.
Finally, let's look at Section 5. We are going to cover an incredibly powerful tool to anchor all this knowledge firmly into your memory, right before you walk into that exam hall.
This quote directly from our source material reveals the ultimate benchmark to test if your revision has actually been effective. Look, reading your notes silently is entirely passive. You feel like you're learning, but your brain is just recognizing the words. But if you can answer specific revision prompts aloud, actually speaking them into the room, you are actively retrieving the information. This process absolutely proves that your grasp on the topic is secure enough to confidently tackle both simple short answer questions and those terrifyingly complex structured problems.
And here they are. These are the 4 specific revision prompts. I want you to write these down right now. Number 1, what is the core idea? Number 2, what changes physically? Number 3, what quantity or graph shows it? And number 4, where is it used? I am telling you, if you use these 4 prompts aloud for literally any system of units you study, I guarantee your grasp on the material will become totally secure. You will walk into that exam feeling unstoppable.
I am going to leave you with this final provocative challenge, pulled directly from a real exam structure. It challenges you to apply the DREA method right now in your own life. Name one real-life example where a system of units matters, and justify the link clearly using the physics behind it. Can you do it right now? If you can, you are ready. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment.
Like and share this video with a study partner. Ace the exams, your Cambridge success starts here. Thank you so much for joining me on this explainer, and keep asking those why questions.